Alright, after having done haloalkanes and haloarenes, today we are going to start with alcohol, phenols and ethers. Alright, as you know, earlier we had talked about alcohols, phenols and ethers in the sense that, when we talk about haloalkanes, it is basically, haloarenes are these and you have C2H5Cl. This is a very basic thing that when we are now going to talk about alcohols and phenols, you know that this halogen is just going to be replaced with the functional group of alcohol, which is OH, and here phenol will be here put as OH here. Now as you can see here, you can think that this particular alcohol, when it is like, when this particular alcohol that I talk about, when I talk about it, you can feel that this contains an OH group. So from the very thought, when you look at it, you may feel that it contains an OH group. Then you can distinguish, can you think about it, whether it is going to act as an acid or a base? You know that when according to the Arrhenius concept, when we talk about H plus ions donation, we talk about acid, and when we talk about OH minus ions, we talk about base, right? Here in this case, when we talk about alcohols, what do you think can they act as? Base. You think because it is having an OH, but remember that these alcohols act as an acid. Now what's the reason behind that? See, when I am talking about CH3, say CH2 and OH, this is how I am drawing. Now the breaking or the dissociation of the bond will depend upon which bond is more polar. ठीक है? क्योंकि जितना ज़्यादा polar मतलब क्या? Separation of charges. जितना ज़्यादा separation of charges होगा, उतनी easily bond will get broken. So either this bond will get broken or this bond. The chances are this is delta negative, this is going to be delta positive, and this is also going to be delta positive. Now it just depends on whether this bond is more polar or this bond is more polar. So remember that alcohols are acidic but weakly acidic in nature. They are only weakly acidic in nature, but they can give OH minus ions when they undergo the nucleophilic substitution reaction. They can undergo nucleophilic substitution reaction, means now instead of OH, you can have any other group which can act as a nucleophile. And just to remind you, I hope you remember that nucleophile are electron rich and electrophiles are electron deficient. Okay. Now let's talk about from the very basic again. Whenever we have, say, a straight chain compound or a normal alcohol, we call it aliphatic alcohol. Whenever you have it along with the benzene ring, you call it aromatic alcohol, which is, in this case, this has a common name which is known as phenol. Again, here remember that phenol is going to be acidic in nature. That's a very basic thing. We'll elaborate it as we move on. Then again, you know that your alcohols can also be segregated into primary, secondary and tertiary alcohols. This goes in line according to your alkyl halides only. If the alpha carbon, the very first carbon which is directly attached to OH, is attached to only one more carbon atom, then you call it 1 degree. When this carbon is attached to 2 carbon atoms, the alpha carbon, why am I calling it alpha? This is the first carbon atom which is directly attached to your functional group. So when this is attached to 2 carbon atoms, it is secondary, right? So it will be R2CHOH. And when this is attached to 3 carbon atoms, you call it tertiary. Again, the reactivity order will be, remember, the reactivity order will be the same as in case of alkyl halides. So that is why I told you that if you do haloalkanes and haloarenes with a deep understanding. The rest of the chapters are just an extension of the understanding to other functional groups. So here again, remember, reactivity का मतलब क्या? If I am talking about reactivity, breaking of the bond by when it has to get replaced by another say substituent, which can be a nucleophile, because OH कैसे अलग होगा? As OH minus ion, and when OH minus ions get separated, when OH minus ion gets separated, then we are talking about and it gets substituted, we are talking about nucleophilic substitution. Now something that we couldn't throw light on last time, when we talk about nucleophilic substitution of course reaction, then in that case remember that we can talk about two types of nucleophilic substitution. It can either be SN1 or it can be SN2. This is substitution nucleophilic unimolecular reaction. This is substitution nucleophilic bimolecular reaction. You generally talk of it in haloalkanes, haloarenes, but because we had less time last time, we couldn't discuss it. So just pay attention to this, that if I am talking about the substitution of this, say conversion of an alkyl halide to an aryl halide, if say I had a group like R, alright, so in this particular case, or let me talk about first primary. If I am taking 1 degree, say alkyl halide, alright, I am taking 1 degree alkyl halide means this is CH2. So this CH2 can also be written as this because it is, hydrogen is small in size. So I can generally write it like this. This is my primary alkyl halide. Now if OH minus ion has to come in place, I am talking of this because here now I can be talking of the preparation of alcohols, right? So in this case, how will this OH minus approach? Cl minus is on one side. You have the orientation of hydrogens in such a way because they are small in size, and you have R like this. So it has sufficient space to allow the OH minus to attack carbon from the other end. If Cl minus is a bulky nucleophile and the incoming nucleophile also needs some space, then it of course will be coming in from the side which has space from where it can attack. So it can come from the opposite side and attack it. So in this particular case, this is a primary alkyl halide, alright, where I am trying to replace my Cl minus with OH minus ions. So here in this case, what is happening now? This is my very first step, which is the slowest step, and you've done it in kinetics that the slowest step is the rate determining step. So you have the rate determining step here, and how many chemical species are involved? 1, 2. Do you get it? So because 2 species are now involved, you call it and SN2, because it is what is happening? Substitution of a nucleophile, and it is a bimolecular reaction. So you have 2 molecules now reacting in the rate determining step. So what will happen? Your OH minus is trying to attack is trying to attack your carbons, which is, you know that this is delta positive. This is because of the polarity in the bond. So this will be delta positive, of course. This will be now negative because your negative charge was coming in. Your Cl minus will be about to leave. You are not doing anything to your R and H2s. So here your carbon, this is known as the intermediate transition state. And यहाँ पे carbon की valency roughly कितनी है? 1, 2, 3, 4, 5. You know that carbon cannot extend its valency to more than 4. ठीक है, तो ये तो बहुत unstable state है. तो what will happen? Cl will leave immediately. So this is actually happening in a single step, and both the molecules are reacting, and you are getting what now? You are getting R, C, H, H, and you are getting your OH here. So one thing that you observe, look up. We are talking about 2 types of nucleophilic reactions. One is a substitution nucleophilic unimolecular SN1 and the other is SN2. Very clearly, हमारे पास options क्या हैं? We can either have a primary compound, or we can have a secondary or tertiary. Primary के case में steric hindrance कम है. What is steric hindrance? It is due to the bulky groups which are generally attached which try to repel. ठीक है, यहाँ पे जगह बहुत थी तो steric hindrance कम है. So what this OH minus does is it will come and directly attack at the carbon group alpha carbon, which is gonna have a polar bond with Cl. This bond will be polar in nature. So naturally सिर्फ इन चारों में से किसके chances ज़्यादा हैं break होने के? इसके. So now this OH minus will come from the opposite side and attack while your Cl is preparing itself to get cleaved. So when it does that, both the molecules are reacting in one step only, such that OH minus comes and attacks at C, forms a transition state, intermediate one, which is a very short-lived one. Okay, and immediately your Cl leaves, so you will have plus Cl minus here. So OH minus was attacking, Cl minus has left, and you have got this alcohol. This again is RCH2OH, which is a primary alcohol. But what has happened in this case? Your Cl was facing on this side. Now your OH is on the opposite side. So this is some kind of an inversion in configuration. The inversion in the system. This is also termed as Walden inversion. Remember that Walden inversion is happening in which case? It is happening in case of SN2, and SN2 is happening for 1 degree. ठीक है, क्यों? क्योंकि 1 degree में there is a choice that it can attack from the opposite side. So both the molecules can react in the very first step itself. It is going to be a substitution nucleophilic bimolecular reaction. So 1 degree will undergo SN2. Understood all of you all? Okay, any doubts anywhere? Okay, now the next thing is, if I talk about now say a 3 degree. Now look up.
Could you please explain why it is called Walden inversion?
This is named after the scientist. Inversion because you know your Cl was here. If I invert the system or rotate it by an angle of 180 degrees, ये Cl अभी ये R है, ये कार्बन है और ये Cl है. अब Cl इधर था न्यूक्लियोफाइल और अब कहाँ हो गया? तो मैंने क्या करा? Invert. So this is like inversion. Now your OH is on this side. Cl was initially on the RHS. Now it is on the OH is on the LHS. So there has been an inversion, and the attack has not been from the same side.
Bounce back with it.
क्यों?
If there is Cl.
Unless and until you bring about the change. So now just look. You will understand it better when we talk about the other one. Look up all of you all. ये समझ में आया? You will find it in all the books if you've understood this. Note it down later, please look up. Now if I'm talking about a 3 degree alcohol, तो tertiary alcohol में क्या है कि ये तीनों मिथाइल ग्रुप्स या इथाइल ग्रुप्स या जितने भी लंबे कार्बन चेन्स हैं, all are bulky groups, alright? क्योंकि tertiary में your carbon is attached to 3 more carbon atoms. So naturally these are having a lot of steric hindrance. Chemical term, scientific term. So they are having a lot of steric hindrance due to the bulky alkyl groups attached to carbon. So as a result of it, there is no place for Cl to enter. Or if I am talking about the formation of OH from alkyl halide, say if I am talking about now a tertiary alkyl halide, so this is the case. So in this case, there is just no place to attack from where it can attack. So what will it do? It will first get rid of the Cl minus. Why? Because it wants to create space for the other nucleophile, जिसने भी आना है X minus. So what will it do? अब क्योंकि जगह ही नहीं है उसके अटैक करने के लिए, तो what will it do? In the very first step, which is the slowest step and the rate determining step in these cases, you will have the formation of carbocation first. So you will have carbocation getting formed plus Cl minus. This is your first step. Your first step is the rate determining step. अब second step में क्या होगा? Second step में the carbocation which has got formed will interact with your very good your OH. So what you have is this carbocation which is formed will now react with OH minus ions or whichever nucleophile you're actually substituting it from with sorry, so you will get it, OH minus ions will easily attack from this side, so you will have the tertiary getting formed like this. So this is your OH. Now just look, Cl was on the right hand side, now the incoming nucleophile is also on the right hand side, so you call it retention in configuration. That means जहाँ मेरा nucleophile था हमने वहीं पे वो आ पाया. So here in this case the rate determining step, okay, so here in this case what we have is the rate determining step has only one molecule. So that means this 3-degree alkyl halide, that is tertiary alkyl halide, is now undergoing SN1. Why is it going SN1? Because only one molecule is involved in the rate determining step. So you call it a substitution nucleophilic unimolecular reaction. क्योंकि unimolecular पहले involved है, then it is actually forming a carbocation and this carbocation plus Cl minus. Okay, and then this carbocation gets the attack from this side and you get the retention in configuration. Understood clearly? क्योंकि SN1, SN2 important है and you should know the difference between the two. So remember, if it is a 3-degree alkyl halide or alcohol, it will undergo SN1 and if it is primary, then it will undergo SN2. SN2 का मतलब rate determining step में कितने reactants हैं? 2. और SN1 का मतलब rate determining step में 1. Inversion of configuration किस में होती है? SN2. Inversion in configuration किस में? Walden inversion किस में हो रही है? SN2. और SN1 में क्या हो रही है? You are getting retention in configuration. Clear with that? So this is just the primary difference. So if you look at it, an easy way to remember is 3 degree है तो SN1, 1 degree है तो SN2. It's just not the same. 1 degree को SN1 तो बोलना ही मत. 1 और 1 will not go hand in hand together. ठीक है? तो remember this. 1 degree है, primary है, तो it will undergo SN2 mechanism. And अगर if it is a tertiary, it will undergo SN1 mechanism. This you can remember. So where do you want me to repeat from now? Yes? No, this was a question to other centers. Yes?
About the 2 degree.
See, 2 degrees actually depends. If it has a lot of bulky groups, then you know that the bulky groups will undergo SN1. क्योंकि पहले वो अपना nucleophile निकालेंगे, जगह बनाएंगे, फिर अंदर लाएंगे. You know, if this room is going to be very cluttered and if we need to get something from outside, what do we need to do first? First we'll actually put things out, then we have to get new things in. But if you have a lot of space, you can think of additional things which can happen. Alright, so now just a quick repetition because others want me to repeat SN1 and SN2. Just a quick repetition. See, if I want a primary, I have a primary alkyl halide. ठीक है, प्राइमरी अल्काइल हैलाइड मतलब the attack will be at this carbon atom. ठीक है, alpha carbon atom, this is going to be more polar, CCl bond here. So if this is going to be more polar, I can actually write the orientation of this primary also as CH, CH3 and Cl. This is the orientation. Now if I take an OH minus ion or any other nucleophile which is to come and attack at this carbon atom to make CCl cleave, then this OH minus ion will come from this position and attack on the carbon atom right here. Because these atoms or the groups in the vicinity are not that bulky. So they are giving enough room for OH minus to enter. But carbon cannot survive with a valency of more than 4. So naturally the already existing group will have to leave. So in this case, this is the intermediate transition state. So then you get COH and you have CH3. So CH3, CH2, OH now. But remember, this is known as how many molecules involved in the, this is a one-step reaction. It is happening in one step only. So this is happening in one step, but since two molecules are involved, it is an SN2. Now what have you learned from SN2? Remember that SN2 is the one which is undergoing, yes, it is undergoing Walden inversion. Then which type of molecules easily undergo SN2? Primary alkyl halides or primary groups, basically primary compounds, 1 degree compounds are undergoing SN2, Walden inversion is happening, and it is also witnessing the formation of a transition state, because you can get now different multiple choice questions based on it, that a particular compound AB is getting formed with the formation of a TS, transition state. Suggest what would the molecule be. Then they'll give you different examples, primary, secondary, tertiary, and you have to, and none of these, all of these. So you have to pick up the correct choice. So out of them, the clear-cut choice will be that of a primary, if it is in the formation, because there is no transition state formation in case of SN1. So this is clear. Now in case of SN1 now, we have, if I talk about now a tertiary group, in case of a tertiary group, what we have is, you have CH3 here, CH3, and say we are taking the most basic alkyl group, that is CH3. Even these are bulky in nature. So what will happen if I want now Cl minus to come and attack, or if I want to replace this Cl with an OH minus ion. Now because this is tertiary in nature and it has no room for the incoming nucleophile to enter, so in that case what will happen, it will make Cl minus leave first. So when it will make the Cl minus leave first, you will have a clear-cut formation of a carbocation. So remember, where are you getting the formation of a carbocation? In case of SN1 now, and this is OH minus ion. Now here, Cl minus ion. So Cl minus ion has left now, right in the first step, and the first step involves only one molecule in case of tertiary. So that is why tertiary will undergo SN1 mechanism, because only a single molecule will be involved first to form the carbocation plus the nucleophile which is leaving now, and the second step involves the attack from the nucleophile, which in this case now we are using as OH minus ions. This OH minus ion will come and attack at the carbocation, and you will get CH3, CH3, CH3 and your OH on the same side as was your previous nucleophile. So here in this case you get retention in configuration. So there are many questions which are related to it. Which of the following reactions will undergo Walden inversions? So you have to look for a reaction where there are chances of SN2 to happen, and SN2 will happen only in case of primary. तो ये सब interrelate करना है, सिर्फ ऐसे ही नहीं सोचना Walden inversion मतलब SN2. SN2 happens in case of primary. तो आपको एग्जाम में अगर पूछा होगा which of the following is undergoing Walden inversion, they'll give you examples of primary, secondary and tertiary. Then in which case do you observe retention? That is SN1, or in case of tertiary. So both the things have to be remembered. Which witnesses the formation of a transition state? SN2. And which witnesses the formation of carbocation? SN1. Alright. So this is what you are supposed to remember. Now this is only a simple mechanism that could have been done in either the chapter of haloalkanes or haloalkanes, or here in case of aliphatic alcohols. But now let's talk about alcohols now. So just pay attention to this. What we have is, you can have 1 degree, 2 degree. Now remember that there are monohydric alcohols also. You can either have monohydric alcohols or you can have dihydric, or you can have trihydric alcohols also, or you can have polyhydric. That depends upon the number of OH groups. Like for example, monohydric, the general examples are ethyl, you have methanol, ethanol, etc. Di, you can have ethylene glycol, CH2OH, CH2OH, triglycerol, CH2OH, CHOH, CH2OH, and polyhydric. Then you have when you have multiple number of OH groups. Okay, now if I talk about phenols, you know that the general name given to this is phenol. When we have dihydric aromatic alcohols, or in this case, what you have is this is phenol. When I put it here, this becomes this is catechol. Then you have resorcinol, and then finally you have quinol. This is when it is ortho position pe OH, then it is catechol. When it is at meta position, then it is resorcinol, and when it is at para position, then it is quinol. Okay, I'll just put the names again. Remember that a bigger picture. When you have this is your phenol. When you have another OH at the ortho position, it is catechol. Okay, when it is at meta position, learn it right here, right now. When it is at the meta position, it is resorcinol. Okay, and when it is at para position, resorcinol mein O nahi aata. This is not resource. So this is resorcinol is RESORCINOL, resorcinol, and then you have when it is at both are at the para position, then you have it as quinol. Okay, go through. Remember that in each of these cases, when your carbon is surrounded all by single bonds, what is the hybridization in carbon?
Single bond, sp3.
sp3. When it is surrounded by a double bond and triple, of course, sp. When your oxygen is surrounded by two bonds, two single bonds, your oxygen is always sp3 hybridized. Okay, please remember that. Carbon थोड़ी है, carbon के आसपास तो 4 single bonds होने चाहिए ना. Oxygen has a valency of 2. You remember O is 2 minus 11th class or even before that. So oxygen has a valency of 2. When it has 2 single bonds around it, it is always sp3. And the bond angle by taking O as the center will then be 109 degree 28 minutes. Okay, or 109.5 also is said sometimes. Okay, so now let's come on to the nomenclature. You know that this will generally be named, and the name will be ending with all. Okay, so here in this case, if you have to talk about it, if I draw the, you give me the IUPAC name for glycerol.
Propane 1,2,3 triol.
This is propane 1,2,3 triol. If it is for this, alright, name this. This is actually cresol. Remember the common name for this because sometimes in the question it comes as a cresol directly. So when phenol has a CH3 group attached at any of the positions, then it will be known as orthocresol. अगर यहाँ meta position पे होगा तो metacresol और paracresol. Okay. So then we have this as one of them. Let me just give you one more example. Just write out. This is an cyclo alcohol. Now you know that because OH will be given a preference over other functional groups. Here you have just the alkyl groups. What will be the name of this? Yes, 2,4. Very good. Or even if you don't write 1, it will do. So it will be 2,4 dimethyl cyclopentanol. 1 is optional whether you write it or not. So it will be 2,4 dimethyl cyclopentanol. So you can do the nomenclature, of course. Now let's come on to the preparation of alcohols quickly. Some of the preparations are easy to be noted because you know all are familiar with alkenes. ठीक है? तो alkenes की अगर हम alkenes generally have a double bond. If I talk about the simplest alkene, which is ethene, it is double bond. So when I actually add the simplest thing, because I need to add one H here and an OH here, you know they always undergo addition reactions. So if I add water to it, HOH to it, so then in that case what will happen? It is a symmetrical alkene. So in this case you get the formation of an alcohol simply, that is CH3OH. So from the alkenes the preparation is very simple. You simply add water to it and you get CH3CH2OH. This is a way of checking also whether you're awake or not. We're just cutting out a reason, wrote it by mistake. Alright, so you have an alkene and you add water to it. In the presence, remember that this is always added in the presence of an acid. Now here there's a point. Before I move on to the mechanism, which is actually important. Here, when you have an unsymmetrical alkene, again it will follow Markovnikov's rule. So remember that if you have an unsymmetrical alkene, then in order to get a secondary alcohol, it's a good method. Because what is it? Let's take up an example. This is an unsymmetrical alkene. 1-propene is an unsymmetrical alkene. When I talk about the addition of water to it now, you know that hydrogen goes to that carbon atom. Addition to सिर्फ double bond वाले carbons पे होगी. Remember that hydrogen moves to that carbon atom which has greater number of hydrogen atoms. So naturally, what will be the choice like? H will go to CH2 and your OH will go to this. So whenever you have an unsymmetrical alkene, the chances are that you will get the formation of a secondary alcohol. ये याद रखना. अगर अच्छा मान लो अब अगर question में आ जाए, you have to prepare. Did you understand this? So this means that whenever you add water to an unsymmetrical alkene, it will never give you a primary alcohol. ये तो याद रहेगा. Because primary तो तभी आएगा जब anti जाओगे Markovnikov के rule के. So in this case what you have is CH3, CH, double bond CH2 and you are adding water to it. You know that your H and OH will attach in such a way that hydrogen goes to that carbon atom which has greater number of hydrogen atoms out of these two. So naturally you will get the formation of, stay awake because I may write wrongly on the word. So it is CH3, CHOH, CH3. So it will always give us a 2-degree alcohol. Now the question is, if in the examination or in any paper you're asked to form a primary alcohol from alkene, so what will we do? If we are asked to form a primary from this, तो आपको पता है कि primary तो water in the presence of peroxide, पर ऐसा तो reaction है ही नहीं. So what we'll do? We'll add HBr in the presence of peroxide, yes. And what will it give you? CH3, CH2, CH2Br, and then you can actually replace it with NOH. How? You can add aqueous KOH to form a primary alcohol which is going to be this. So this is now substitution reaction. अब सिर्फ Br को replace ही तो करना है. So remember that you can actually prepare primary alcohol also from an alkene and you can prepare a secondary alcohol also from an alkene. Secondary will be formed only when your Markovnikov's rule is followed and your primary will only be formed when you make it fall under the anti-Markovnikov's rule category by making use of peroxide and HBr. Okay, so now let's talk about the mechanism. one has to talk about the mechanism. What happens is, जब H2O reacts with H plus, तो क्या बनेगा?
H3O positive.
H3O positive hydronium ions. All right. This hydronium ion, you have C. This is your simple alkene, CH2 double bond CH2. This will actually interact with your hydronium ion in such a way that you have your one of the H attacking one of the H plus, क्योंकि O के ऊपर अभी बहुत प्रेशर है. O की वैलेंसी मैक्सिमम कितनी हो सकती है? 2. It is an extended coordinate covalent bond. याद है? Coordinate covalent bond पढ़ा है. So this is an extended one. So H plus is too keen to leave, so that it gets back into the water form. This H plus will come and attack carbon. यहाँ पे double bond है. This double bond will shift. Alright. When this double bond shifts here, let me just know. When this double bond shifts here, this gets a negative charge, or I mean, this has a double bond. Look at this. If this has a double bond and the double bond migrates in this fashion, what will be the charge on this? It will be negative, and this will be when the charge completely gets transferred. So one of them will be delta negative and the other will be delta positive. So when your H plus comes and attack here, you know that it will form what? ये नेगेटिव है क्योंकि बॉन्ड अगर जो इसके पास शिफ्ट होगा वो नेगेटिव होगा और जो शिफ्ट करेगा वो पॉजिटिव होगा. तो यहाँ से because H3O plus has an added H plus ion to it, that H plus will come in the negative carbon, so it will come here, and then you will have what? C H2 and a positive charge, or the way you are comfortable with. You can put the positive charge like this also. Alright, it gets a positive charge. Now what are we supposed to add? We will now be adding OH minus ion. So what have we generated from here? We have generated the carbocation from here. So now in the second step, this is kind of the first step. What is happening in the first step? You know you've already added acid. That acid is forming hydronium ions. Now that hydronium ion is attacking your alkene in such a way that it is now forming a carbocation from the alkene. Now the second step would be the attack of nucleophile. And how will the nucleophile attack now? You have your CH3 because H has already got attached, and you have your CH2 positive. What is your nucleophile? That is H2O. Your nucleophile is H2O. Oxygen has lone pair of electrons. In fact, two lone pair of electrons. Negative charge कहाँ आएगा? Positive के पास. So clearly, your HCH, you'll have CH, H, and you'll have O, H. तो कहाँ positive charge लगाऊं? क्योंकि ऑक्सीजन के पास अब 2 की जगह कितने 3 bonds हो गए. ठीक है. So naturally, now again oxygen has 3. So what will happen now? When you have CH3, CH2 and OH2 with a positive charge here, this will again interact with another water molecule. ठीक है. And you know H plus would be now willing to cleave. H plus would be willing to cleave easily now. So in this case what we have is, you have your H plus will go from here and get attached to this oxygen of water. So what will it form? It will form your CH3, CH2, OH plus H3O plus, which was initially formed. So you've gotten back the H plus ion which was actually initially being utilized. So basically your H3O plus ions act as a catalyst, which is regenerated or not utilized in the reaction at all. So the first two reactions that we simply written were the utilization of the H3O plus to form your carbocation. Once your carbocation is formed, then it gets the nucleophilic attack. In this case the nucleophile is OH minus only, तो water से ही आएगा. तो वहाँ से when it attacks, you get back your H3O plus and the formation of alcohol. Clear with that? Okay. Next, we can also talk about the formation. तो अभी तक हमने अल्कोहल की कितनी फॉर्मेशंस की बात करी? We just talked about the formation from alkenes. ठीक है, alkenes में सिंपल क्या डालना है? पानी. और ये तो याद ही रहेगा, OH and H will get attached. And पानी in the presence of H positive acts as a what does it form with water first? H3O plus, and followed by the formation of carbocation, and then you get the formation of alcohol. All right, next what we talk about is also the formation from alkenes in another way. This is an important reaction which is known as hydroboration reaction. You have BH3 whole twice. You know what is B2H6? It is diborane. So that is BH3 or B2H6. ठीक है? BH3 can also of course be written like this. Remember that this gets added up according to the anti-Markovnikov rule now. ठीक है? What is the speciality? अभी हमने alkene से formation की बात करी थी. तो alkene में जब water डालोगे ये simple reaction तो हर बच्चे को याद रहेगी. पर अगर हमें alkenes, अगर if I have to make from alkenes a primary alcohol directly, हमने दो स्टेप में कैसे बनाया था? peroxide यूज करके प्राइमरी एल्काइल हैलाइड बनाया, फिर उससे प्राइमरी अल्कोहल बनाया. पर अगर एक सिंगल स्टेप में बनाना होगा तब हम क्या यूज करेंगे? हाइड्रोबरेशन. ना हाँ, we'll use this. In this case what will we do? We add BH3 which is nothing but HBH2, and B2H6 basically it exists as diborane, as a dimer. So in this case your H will get attached and BH2 will get attached. So remember, this follows anti-Markovnikov's rule, which means that your hydrogen will now go to that carbon which has less number of hydrogen atoms. So here what we have is hydrogen goes to that carbon atom which has less number of hydrogen atoms. So here what we'll have is CH3, CH2, CH2, BH2. ठीक है? Once this is done, what we get is you add another, this undergoes reaction with another alkene now. Alright? When this undergoes reaction with another alkene, say you add CH3, CH, double bond CH2, again your hydrogen from here, because this BH bond is more polar. So hydrogen from this will go to carbon which has lesser number of hydrogen atoms, and the rest of the molecule or the rest of the things which are like left, this B will attack the CH2 which has greater. So your hydrogen will again go to this. So what we will get is CH3, CH2, CH2, and CH2 में क्या ऐड हो गया? B, H, B, H, और बाकी का CH2, CH2, CH3. This was nothing but left and right is just the same. So it can also be written as CH3, CH2, CH2 whole twice BH. अभी भी एक hydrogen बचा हुआ है which can get attached further. So what I'll do is add, it goes and gets added to another molecule of alkene. So you're seeing that the yield will increase in this case. So what we have here is we get CH3, CH, double bond CH2, and this gets added up as CH3, CH2, CH2 whole thrice now, and B. And then finally what you do is, yes, you carry out the oxidation by adding H2O2, very good, in the presence of, very nice, in the presence of OH negative, and what you get is, you get the alcohol. CH3, CH2, CH2, OH plus H, boric acid, H3BO3. Clear with it? Then this is an important reaction because this is following anti Markovnikov's rule. So directly if you want it from alkene, so this is the step that you will follow. Hydroboration followed by oxidation. Done?
It's not direct. It is going so many.
Actually it is direct because you have an understanding that this is how it is going stepwise. Otherwise what you have to do is you just have to take your alkene, add अगर इसको लैब में अगर करना होगा तो अगर आपको नॉर्मल एल्कीन से वाटर मैंने दिया है और नॉर्मल एल्कीन से प्राइमरी अल्कोहल बनाना है तो पहले आप उसके अंदर पेरोक्साइड HBr डालोगे, फिर उसके बाद उसके अंदर आप वाटर डालोगे and then you will have a side product also, right? Because in that case you will get a side product also. Now here in this case what's the best thing that you are getting what is the side product? Boric acid. तो इसके अंदर आपने कुछ नहीं करना, you just have to take your alkene and you have added only diborane to it. After adding diborane you've carried out the oxidation. This is like a better yield. Why is it giving a better yield? Because 3 molecules of alkenes are being consumed for 1 molecule of diborane. तो जरा सा एक्स्ट्रा हमने डाला तो हमारे 3 मॉलिक्यूल्स कन्वर्ट हो गए टू अल्कोहल, तो नेचुरली यील्ड विल बी ग्रेटर इन विच केस. तो व्हेन यू परफॉर्म इट इन द लैब यू एक्चुअली चेक द अमाउंट ऑफ इट व्हिच इज फॉर्म्ड. सो व्हिचएवर गिव्स द बेटर यील्ड इज कंसिडर्ड टू बी अ बेटर मेथड, बट यू डोंट हैव टू गो इनटू द डिटेल्स, यू जस्ट नीड टू अंडरस्टैंड एल्कीन से डायरेक्टली अल्कोहल बनाना है तो हाइड्रोबोरेशन ऑक्सीडेशन, और अगर इन आई मीन इफ यू हैव अ चॉइस and if you don't remember then water of course is an option followed by I mean it has to be actually you have to do the anti-Markovnikov's rule using HBr peroxide then and follow it. Right, okay. Then next what we can talk about is by reduction of aldehydes and ketones. You can form it from carbonyl compounds also. How can you form it from carbonyl compounds? Now let's just take up an example. First of all, you know what are carbonyl compounds? You have CHO and C double bond O. So you know that basically you have H and C double bond O here. So naturally whatever you add up to it is going to get added up to this carbon and this oxygen, because whenever you add a reagent to any double bond compound, the chances are that first it may undergo addition reaction with the attack at the centers which are around the double bond. So यहाँ पे attack होगा और यहाँ पे attack होगा. So when you have an aldehyde now, in case of an aldehyde, you add simply H2 in the presence of PD. You know if H2 is added up, so it will become RCH2OH. Okay, so this is the simplest preparation. Now if you have a this is like if you want from carbonyl compound a primary alcohol. What are you getting in this case? RCH2OH. If you want to prepare a simple secondary alcohol, use a ketone. So in this case, when I now do the same reaction by addition of hydrogen in the presence of a catalyst, this catalyst can be platinum, palladium, nickel, anything. So the hydrogenation reaction can be carried out and what you get is RC double bond O, what you get finally RCH2OH R dash. So that is a secondary alcohol. Then yes, from carboxylic acids next. So remember that in case of carboxylic acids, what are you using? And followed by water. So you get RCH2OH. You can have it from different derivatives of acid also. You can actually carry out the reduction of different derivatives of acid. What are those? You can have an ester. You can have say using an ester also. So if I talk about by reduction of carboxylic acids, you know what is getting formed in this case? RCH2OH. So again in case of this, you add hydrogen in the presence of a catalyst. This will give you RCH2OH plus R dash OH. So in this case, this and this are forming. So remember that the number of carbon atoms are remaining as the same, with a cleavage here in this case. Now the best method or one of the important method is by making use of Grignard's reagent. How? by making use of Grignard's reagent. Remember that in this case, if this is your, what is the difference in aldehydes and ketones basically? In case of ketones, you have an R and an R. In case of aldehydes, only an alkyl group is replaced by an H. So here if I add Grignard's reagent, remember in case of Grignard's reagent, the most electropositive element is your magnesium. So it will have a delta positive charge and your carbon will be electronegative here. So in this case, I would rather not call it electronegative. You can say it develops a delta positive charge and this has a delta negative charge. So this bond gets cleaved according, and here for aldehydes and ketones, this will help you in the next topic as well. Remember for aldehydes and ketones, you have a delta positive charge always on the carbon and a delta negative charge always here. And जो भी reagent add हो रहा है to aldehydes and ketones, it generally forms an adduct. What is an adduct? Whenever you have an aldehyde or a ketone, आप सबको पता है aldehyde और ketone में what we have is, in aldehydes and ketones में what we basically have is you have a double bond, C double bond O. तो जो भी reagent हम add कर रहे हैं उसके अंदर से पहले ही देख लो कि इलेक्ट्रोपॉजिटिव क्या है और इलेक्ट्रोनेगेटिव क्या है. जो भी इलेक्ट्रोनेगेटिव होगा वो कार्बन को अटैच हो जाएगा और जो भी इलेक्ट्रोपॉजिटिव होगा वो ऑक्सीजन को. दिस समराइजेस द एंटायर केमिस्ट्री ऑफ एल्डिहाइड्स एंड कीटोन्स एज वेल. सो व्हेनेवर यू टॉक ऑफ Grignard's reagent, इसका भी याद रखना कि it is always the magnesium which has the delta positive charge and it is R which has the delta negative charge. So naturally your delta positive will go to this. So what you get is, you get C, R and R was already there. Alright, let me just, if you want to have different groups, so it will be R dash. यहाँ पे अब what will happen, your R double dash is having a delta negative charge. तो ये delta negative charge वाला will go easily to this carbon. So it will form R double dash and you have O MgX. And now you just have to add water to it. And when you add water to it, you know that again OMgX bond is the most polar here. So your H will come with O and OH will go with Mg. So you will get a formation of an alcohol with an added alkyl group altogether. So this is the formation of an alcohol with an added alkyl group. So now if I ask you, I'm giving you a problem right now. Try to form CH3CH2OH using Grignard reagent. CH3CH2OH from carbonyl compound using Grignard reagent. Did you get the problem?
Yes, ma'am.
You have to form CH3CH2OH using Grignard reagent. So now you have to make the correct choice of the aldehyde or ketone along with your correct choice of the Grignard reagent also. So let me just see how many of you are able to do it, and in the meantime I'll rub the board. So what is the starting reagent that you've used? Okay, you've used CH3MgX. Very good. And what is the carbonyl compound that you've used? So you've used HCHO. HCHO, not CH3O. It is CH2O. Alright. What is this? Formaldehyde or methanol? This is either methanol or formaldehyde. So all of you all know, now the final outcome has to be MgX or OH to alag jayega, right? And of course you're adding water also in this case as a second step after addition of Grignard's reagent. You will take the addition of Grignard's reagent as a first step. So this is going to be a first addition. The second addition has to be water. So if I have to write it directly, you know, जब water last step में add होगा, तो you will get Mg, OH and X. You know that this will of course get cleaved. This CH3 is going to get this CH3 will attach at carbon, so you get CH3 to your C, which already has H2, and this O will definitely in the end become OH. So naturally the choice. So now how do you make the choice? The question is that अगर CH कोई भी अल्कोहल आता है तो चॉइस कैसे करनी है? रिमेंबर कि हमें क्या करना है कि हमें ग्रिग्नार्ड रिएजेंट के साथ जो भी अल्फा कार्बन पे ऐड हो सकता है, अल्कोहल वाले के साथ वाला कार्बन तो ऑलवेज हैज टू फॉर्म योर it always has to form your, what do you call, your carbonyl compound. So carbonyl compound in this case needs only one carbon, and you have to keep the alkyl groups which are attached to your carbon in your Grignard's reagent. So if I give you another example now, you tell me what is the starting product. अब solve नहीं करके देखने दूंगी. I repeat it again. How do you make the choice of the carbonyl compound and Grignard reagent? By just looking at the alcohol. जो ग्रिग्नार्ड रिएजेंट होना चाहिए उसके अंदर हमारे वो वाले अल्काइल ग्रुप्स होने चाहिए जो एक्स्ट्रा नीडेड है, अपार्ट फ्रॉम द कार्बन्स व्हिच आर अटैच्ड डायरेक्टली टू योर OH. नाउ यू हैव टू टेल मी द स्टार्टिंग कार्बोनिल कंपाउंड एंड योर ग्रिग्नार्ड रिएजेंट नाउ, क्योंकि मैं दिखा नहीं रही. All right, you have to tell me, this is again a simple extension. So in this case, so what can be your this thing? Your, it can be CH3 CHO, CH3 CHO, क्योंकि किसी भी एक कार्बन को ले लो, प्लस CH3, क्योंकि हमें अल्फा कार्बन पे जो भी अल्काइल ग्रुप अटैच कर सकते हैं उसमें से एक ग्रिग्नार्ड रिएजेंट के साथ देना है. सो योर ग्रिग्नार्ड रिएजेंट इन दिस केस कैन बी CH3MgX and your aldehyde can be CH3CH2, no, CH3CHO, क्योंकि the number of carbon atoms also have to be maintained. All right, shall I give you another example then? ये now again aldehyde is required here. You needed CH3CHO and you needed CH3MgX, क्योंकि अल्फा कार्बन पे एक मिथाइल लगना था. Okay. Now tell me the carbonyl that you use and the Grignard reagent. देखो Grignard reagent एक ही तरफ का वो अल्काइल ग्रुप हो सकता है, तो एक ही अटैच करना है, तो CH3, तो इसका मतलब Grignard reagent can be CH3MgX and your, that will be propanol, CH3 C double bond O CH3. This is 2-propanol, propanol or acetone. CH3CO CH3 has a common name of acetone. Please remember it. It is important. CH3 CO CH3. Clear with the Grignard reagents method? All right. So you've learned how to make it from alkenes and from carbonyl compounds. From alkenes? Alkenes के दो methods थे. Alkenes के दो method थे. एक by addition of water in the presence of an acid, and the second method was hydroboration oxidation. Okay, that's also called oxymercuration because your oxidation can be carried out in the presence of other oxidation agents also, oxidizing agents also. Then the second method we did was from carbonyl compounds. Carbonyl compounds में एक directly hydrogenation कर सकते हो, ठीक है? Hydrogenation and even carboxylic acids में you can just simply add a reducing agent like lithium aluminium hydride, LiAlH4 add कर दो, so you will get CH whatever RCH2OH basically, ठीक है? और अगर एस्टर है तो दो टाइप के अल्कोहल मिलेंगे, एक इस साइड वाला अल्काइल ग्रुप का अल्कोहल, एक दूसरे वाला, ठीक है? Then when you talk about carbonyl compounds separately, in case of carbonyl compounds when you use a Grignard reagent, this is a step up reaction. Such reactions are called step up. क्यों? क्योंकि इसके अंदर एक कार्बन एटम या ज्यादा, you get an addition of more number of carbon atoms. Okay, Let me just give you one last example and you tell me what will be the choice of Grignard reagent. Ready? Okay. So you will have acetone कैसे? पहले तो Grignard reagent क्या होगा? एक alkyl group उठा लो, तो that will be CH3 CH2 MgX. ठीक है? And what will be your aldehyde now? सिर्फ इसका हाइड्रोजन नहीं तो निकालना है, यहाँ से H और H निकाल दो, that will be CH3 CH2 CHO. हाइड्रोजन is सिर्फ हाइड्रोजन atom. So CH3 CH2 CHO. So this is propanol, not propanone. Somebody said propanone, which is wrong. So this will be propanol. Understood? So you have to make the choice accordingly. I don't think anybody should be having a doubt in it. Clear? Okay. Okay, now next we can also do hydrolysis of alkyl halides. ये तो सबको आता है. Hydrolysis of alkyl halides. Please do it quickly. Hydrolysis of alkyl halides. How do you go about carrying it out? Say RX में क्या डालोगे तो हमें ROH मिलेगा? Yes. RX में alkyl halide में PCl3 वही डालोगे तो, क्योंकि अब इतनी सारी reactions भरी हुई हैं तो naturally I can understand. So you have RX plus aqueous KOH, that's going to give you ROH, and this again happens in the presence of an acid. So you can use H2SO4 here. It can also form from, yes, it goes according to your this thing notes only, RNH2 plus HONO. So what does that form? That forms your, this HNO2 is added in the presence of NaNO2 and HCl. So it's like your similar to your diazotization reaction. So you have ROH plus N2 gas is given out plus water. Okay, and then very, very, very important steps are the formation from the natural products which are available. What are those? You have from sucrose, that is C12H22O11 plus water. In invertase you get what? C6H12O6. Attention onto the board. I think if you learn it up right here, right now, will help you more than what you're doing. So what you have is cane sugar. Cane sugar. Let me tell you, these names of the enzymes are important, which are generally asked. So cane sugar gets converted into glucose in the presence of in the presence of invertase gets converted to glucose and fructose, and glucose and fructose in the presence of zymase then give you ethyl alcohol and carbon dioxide. So the markers are not at all clear. So what we have, I'm just trying to make it better. Please remember here, this is an important reaction, as it is like a method which is employed for commercial preparation of alcohols also. So ethanol being more important, you know which of the two alcohols is the ones which can be taken up easily? Well, ideally, I mean, it should be avoided, but it's used in for medicinal purposes also. So methanol is not at all fit for, all of you all are aware of it. What happens if it is taken? It causes blindness. So basically it should not be taken, and that is when you talk about impure alcohol or some impurity which is added to alcohol. Alright. So then we can then quickly talk about the preparation of phenols. Just go through the preparation of alcohols. It's a very simple one. We've done the preparation of alcohols now from only alkenes and from carbonyl compounds, or if you have any kind of a conversion from alkanes to alcohols, how will you now go about doing it? From alkanes to alcohol. Alkane से अगर alcohol बनाना होगा तो क्या करोगे? एल्केन से alkyl halide बनाओगे, alkyl halide से फिर aqueous KOH डालोगे, and aqueous KOH डाल के you can easily get your alcohol. So मतलब the reactions are very simple. The only thing is that you need to pay attention more towards them now. Say if I have to talk about the preparation of phenol now, look up onto the board. This is which process? Tell me. Very nice. This is Dawes process, and you have in the Dawes. Yes. Dawes process that we done last time. That is chlorobenzene, and when you add NaOH to chlorobenzene at 300 atmosphere and 623 Kelvin, what you get is your phenol. You get phenol. There are other methods also which are important. Remember that this phenol is only formed via the formation of the phenoxide ion first. First you get the formation of ONA minus, O minus Na plus, first you have the formation of the phenoxide ion. What is phenoxide ion? O minus and Na plus, and then finally you add an acid to it to form OH. But in short we know that the main reagent which is used is NaOH. Okay? So little bit of acid is also needed to be added because it forms ONA first, followed by the formation of an alcohol. Alright, next from benzene what you can form is, see benzene may you add oleum which is H2S2O7, and what you get is a sulfonic acid which gets attached onto it, benzene sulfonic acid, and then to this you again add NaOH followed by an acid which is the same as the previous case to get phenol. So from benzene what are the reagents which are used? You use the reagents first of, you used oleum followed by your Dawes process reagents. So next one is you can also prepare it. This is the simplest one which you've done before also, from aniline. Aniline, it's the simplest method. Why? Because from aniline you can prepare your disonium salt, and once you have the disonium salt, by simply adding water to it you get phenol. Okay, another important and the most important, in fact the method is from cumene because it's an industrial process. So basically what are the three reagents from which you have done the preparation of alcohols? What are the three reagents? Tell me. From which you have done the preparation of phenols. One is benzene, then another is chlorobenzene, and the third is aniline. तीनों से आराम से हो जाएगा. बेंजीन में क्या डाला था? Oleum, followed by Dawes process. You don't call this Dawes process because this is from SO3H. So you know how to prepare benzene sulfonic acid also. Now you know how to prepare your alcohol. Alright, from chlorobenzene it's the Dawes process, and then from aniline it's the simplest of all. Okay, now cumene is the most important one because this is the industrial process, and remember industry में वही process use करते हैं जिसमें yield बहुत ज़्यादा हो. ठीक है? So in this case what we have is CH, CH3, CH3. This in the presence of oxygen will actually give you cumene hydroperoxide. Please learn the formula right here, right now. Hydroperoxide is generally an OOH combination which is put up. So this is what it is. You have, and then on addition of an acid, what you get is phenol plus acetone, which is very much commercially important. This side product which is like acetone, both the products are equally important. So what we are doing in this case is from cumene, and let me tell you how is cumene formed. It is by the reaction of benzene with propene. This is how cumene is formed. So remember that you have a propyl group on top of benzene. This is your cumene, and when you add oxygen to it, it forms cumene hydroperoxide, which is nothing but your O simply gets inserted at this position where your carbon is the main active center. Remember, look up, you have cumene. Cumene is nothing but a propyl group on top of it, and it is getting attached at the secondary position of your propyl group. Here when you add oxygen, the two O's enter into the CH bond and they form COOH, which is nothing but forming your cumene hydroperoxide. And then on addition of acid, you simply are left over with OH group on top of benzene, followed with the formation of another side product, which is acetone. Now what is happening? Phenol was what was required commercially, and you're getting a side product which is again commercially important. So that is why this method is very, very, very important. Okay, next, when we talk about the properties, remember that in case of properties, first, let me just talk about the phenol thing. You know phenol is acidic in nature, right? Now, why is it acidic in nature despite having? Very nice, because of resonance effect. All of you all are answering it as the resonance effect. Okay, now, sorry, when we are talking about the resonance effect here, ये क्या है? Phenol. This also has two OH groups. Now you know, in case of alkyl halides, in case of aliphatic alcohols, in case of aliphatic alcohols, you know from last class, this shows what kind of an inductive effect? Plus I. They show a plus I inductive effect. So that means there will be some polarity between the C and OH bond also, which is making your all the nucleophilic substitution simple. क्योंकि वो CO bond अगर polar होगा तभी तो वो टूटेगा, नहीं तो वो हर जगह पे H को देगा. Now because of this plus I inductive effect, your aliphatic alcohols are less acidic. Because of this inductive effect from the alkyl groups, your aliphatic alcohols are less acidic, which is missing in this case. Because benzene shows a minus and your OH will also show plus R effect. यहाँ पे तो oxygen is electronegative, so it's pulling some electron density from your alkyl groups. Now here the oxygen, the lone pair available on it will undergo plus R effect, and they will also undergo resonance. Now you are saying that phenol is acidic in nature. I have a question here. Phenol is acidic matlab it will give what? A phenoxide ion plus H positive. तो resonance effect किस में ज़्यादा है? आपने कहा phenol is acidic in nature because this is something that you learn and you know so much. ठीक है? Phenol you are saying is acidic in nature. ठीक है? Okay, fine. Phenol is acidic in nature because it gives H plus. Why? Due to resonance. किस में? Naturally इसकी बात करोगे, क्योंकि अगर इसमें ज़्यादा इफेक्ट रेजोनेंस का स्टेबलाइजेशन ज़्यादा है तो इस केस में ये इजीली बनेगा, क्योंकि जो ज़्यादा स्टेबल होगा वही बनेगा. So if phenoxide ion is more stable, it will get formed along with H plus. Now the point is, if this is resonance stabilized, then isn't this resonance stabilized? क्यों? जब Cl के पास 3 लोन पेयर ऑफ इलेक्ट्रॉन्स थे तो मैंने उसका रेजोनेंस स्टेबलाइज स्ट्रक्चर अल्काइल क्लोरोबेंजीन का रेजोनेंस स्टेबलाइज स्ट्रक्चर लास्ट टाइम ड्रॉ किया था. इस केस में अभी मैंने बताया OH विल शो प्लस आर इफेक्ट, सो इट विल ऑल्सो फॉर्म रेजोनेंस स्टेबलाइज स्ट्रक्चर्स. क्यों नहीं बनाएगा? ये रहा, ये यहाँ पे गया डबल बॉन्ड और डबल बॉन्ड टुवर्ड्स दी एटम. सो इन दिस केस व्हाट यू हैव इज डबल बॉन्ड बन गया यहाँ पे, क्योंकि O ने दे दिया उसको तो OH और O पे आ गया पॉजिटिव चार्ज. क्योंकि O के पास कितने बॉन्ड्स होंगे? 2 तो नॉर्मल है, 3 होंगे तो उस पे एक पॉजिटिव चार्ज आ जाएगा. दैट इंडिकेट्स योर कोऑर्डिनेट एक्सटेंशन. ओके, सो देन दिस विल गेट अ नेगेटिव चार्ज क्योंकि ये डबल बॉन्ड इधर आ गया. इन दोनों को हमने टच भी नहीं करा. ठीक है, कीप लुकिंग. दिस इज नाउ समथिंग यू नो. द चार्ज विल मूव टुवर्ड्स द बॉन्ड and the bond will move towards the atom. So again in this case you get another structure which is like you have OH positive and then you have a double bond here. इस double bond को हमने नहीं छेड़ा and this will get negative, and then you have other structures similarly. So I'm not wasting time on it. Now let's look at it. You may feel that greater the resonance stabilized structures, greater is the stability. So do you want to say something for it? Why will phenoxide ion will be more resonance stabilized than phenol? But the number of resonance stabilized structures will be the same. क्योंकि अगर यहाँ पे लोन पेयर मूव कर रहे हैं, इस केस में रेजोनेंस कैसे होगा? this negative charge will move towards the bond, because charge always is moving towards the bond, and the bond is then moving towards the atom. So in this case, what is the next structure? The next structure is what? You get O. No, not positive charge. Why not a positive charge here? Because it was already negative. उसने दे दिया, वो neutralize हो गया. तो O with a double bond, and then this gets a negative charge, and this is here. Is this clear? Now again, negative charge towards the bond, and so this will be the next resonance stabilized structure. You have double bond O. यहाँ पे double bond आएगा, ये यहाँ पे आएगा negative, and you have a double bond here. So now here, why do you think phenoxide ion is more stable than phenol? Because in this case there is charge separation, whereas in case of phenol, whereas in case of phenoxide ion, we have only negative charge resonating. Okay? So why is phenol acidic in nature? Phenol is acidic in nature because the phenoxide ion is more resonance stabilized in comparison to phenol. Both are resonance stabilized. दोनों के equal resonating structures हैं. But why is it more resonance stabilized? Because there is no charge separation in this case, whereas there is charge separation in case of phenol. So, okay. Then we have next as we can talk about other properties also, like boiling points. See, in case of aliphatic, alcohols have a higher boiling point in comparison to their comparable alkyl halides. Why? Because in this case there is hydrogen bonding. Boiling point of alkanes are higher than expected because of the intermolecular hydrogen bonding in polar molecules. So we can just talk about the alcohols because they are having hydrogen bonding in them. And then you know that phenols are generally colorless liquids. Phenols का एक और नाम होता है. In many of the books you will find the name as carbolic acid. That's the name of another name of phenols. And because of the presence of polar OH bonds, phenols form intermolecular hydrogen bonding also there. So phenols also undergo intermolecular hydrogen bonding. Remember that now when I talk about the reactions, ROH, whenever it reacts with sodium metal, it will always liberate hydrogen gas. Okay? And hydrogen gas always comes out with a pop-up sound. The pop-up sound is like tuck. Yeah. So you have RONA plus H2, okay? So is the case with phenols. Phenols on reaction with Na will again form what? ONA. So that will be sodium phenoxide. If I have to compare the acidic strength, now you have to tell me the acidic strength for R, सोच के बोलना. बिना सोचे मत बोलना क्योंकि एसिडिक मतलब आई एम टॉकिंग अबाउट द रिमूवल ऑफ H plus ions. I am not talking about the reactivity trend. I am talking now about the acidic character for 1 degree, 2 degree.
1 degree would be more acidic, 2 degree would be less, and 3 degree. Because of the.
You are wrong and she is right. Why? Because now अगर आप 3 डिग्री की बात कर रहे हो तो आप रिएक्टिविटी की बात कर रहे हो और रिएक्टिविटी न्यूक्लियोफिलिक सब्स्टिट्यूशन में व्हेन यू विल बी टॉकिंग अबाउट द क्लीविंग ऑफ दिस बॉन्ड. लेकिन हम अगर एसिडिक स्ट्रेंथ, व्हाट इज द प्रॉपर्टी दैट आई एम टॉकिंग अबाउट? आई एम टॉकिंग अबाउट द एसिडिक स्ट्रेंथ. ऑलराइट, व्हेन आई एम टॉकिंग अबाउट द एसिडिक स्ट्रेंथ, रिमेंबर अगर मैं रिएक्टिविटी की बात कर रही हूँ न्यूक्लियोफिलिक सब्स्टिट्यूशन की, तब आई एम टॉकिंग अबाउट द रिमूवल ऑफ OH माइनस आयंस. क्योंकि OH माइनस आयन हटेगा तो तब मेरा दूसरा न्यूक्लियोफाइल तभी आएगा. और OH माइनस आयन इधर इजीली क्यों हटेगा 3 डिग्री में? क्योंकि 3 डिग्री में इजीली इसलिए हटेगा बिकॉज यू हैव वेरी स्ट्रॉन्ग प्लस I इंडक्टिव इफेक्ट of the alkyl groups attached in 3 degrees, which will put a lot of push in the electron density and will make this CO bond very highly polar. जितना ज़्यादा इंडक्टिव इफेक्ट होगा उतना वो CO बॉन्ड पोलर होगा और उतनी आराम से टूटेगा. तो अगर ये इजीली टूटेगा तो मतलब OH माइनस आराम से हटेगा. इसका मतलब इट विल बी अ बेटर बेस, और अगर ये बेटर बेस है तो इट इज अ पुअर एसिड. सो नेचुरली द एसिडिक स्ट्रेंथ फॉर दिस विल बी द लीस्ट, followed by this, followed by this. So the highest acidic character will then be of primary only, क्योंकि इसके अंदर CO bond की polarity कम है, OH की ज़्यादा है, and we want OH to be broken easily for the acidic character. Okay, the acidic character generally for others, if you compare, your carboxylic acid is of course the most acidic, followed by carbonic acid, followed by phenol, because phenol का dissociation constant is also not very high. So carboxylic acid followed by carbonic acid followed by phenol followed by water, then alcohol. So which means that your alcohols are less acidic than water. So this is to be, gone through. So remember that, of course, carboxylic acids are very, very highly acidic in nature, because carboxylic acids में यहाँ पे in themselves they will have a resonance effect. When they form a carboxylate ion will again be resonance stabilized. क्योंकि carboxylate ion में resonance stabilization कैसे होगी? This is O minus. So ये aliphatic carboxylic acid में भी resonance stabilization है. कैसे? This will go here and this will come here. So the net effect will be that your negative charge remains in between these two oxygens only. So because of that, your carboxylic acids are highly acidic, followed by a simple acid like carbonic acid, followed by your phenol. So that means acids are of course more acidic than phenols, which have a lesser dissociation constant, which are more acidic than water, which is more acidic than alcohol. Acha, idhar na sometimes, please pay attention to this, that whenever you talk of the acidic character, we relate it to a value of Ka. This is known as the dissociation constant. Higher the value of Ka, higher will be the acidity. ठीक है? And remember that there is a value of pKa which is minus log of Ka. तो इसका मतलब अगर Ka ज़्यादा है तो lower the value of pKa, higher will be the acidic character. तो अगर Ka ज़्यादा है तो acidic character ज़्यादा है, लेकिन अगर pKa कम है तो acidic character ज़्यादा है. ठीक है? So these things are to be remembered, because sometimes आपको तो direct question में लिखा होता है pKa values. अगर ऐसा आता है तो then it's like a wonderful thing, because you get the answer in the question itself. pKa value से ही you get to know about the acidic strength. So a lot of indication comes from there. Then we can talk about alcohols are involved in a very important reaction which is known as the esterification reactions. ठीक है? Alcohols actually are involved in esterification reactions. What are esters? R, COO, R dash. So any other group, just in case if you do not have a repetition. So in this case I'm just putting up the reaction quickly. You have ROH plus R dash COOH. Remember esters कैसे form होते हैं? Alcohol plus any acid or acid derivative. कार्बोक्सिलिक एसिड, ये कार्बोक्सिलिक एसिड का डेरिवेटिव. इसके डेरिवेटिव्स क्या होते हैं? जैसे इफ फॉर एग्जांपल, let me just first write down this reaction, then I'll talk about the derivatives. This is actually a reaction which occurs in equilibrium. That's like a reversible reaction in the presence of H plus forms. अब देखो यहाँ पे H2O निकल जाएगा and you will have R dash COOR. What are the other derivatives? अगर मैं R dash डेरिवेटिव किसको बोलते हैं? मैं इसको डेरिवेटिव क्यों कह रही हूँ? बिकॉज ये तो कार्बोक्सिलिक एसिड है. रिमेंबर कार्बोक्सिलिक एसिड में जब मैं P2O5 डालूंगी, P2O5 जैसे ही मैं बोलूंगी या कहीं पढ़ोगे तो याद रखना इट्स अ डिहाइड्रेटिंग एजेंट. P2O5 will immediately extract what? It will extract water. So the moment, not in this case, because it has to be very strong dehydrating agent. So a little heat is also to be supplied whenever you add a dehydrating agent to provide the. So what happens here? Dehydrating agent P2O5, so it will take out water. When it takes out water from here, it forms RCO, O, R dash CO. This is your anhydride. Okay. Now this anhydride is also an acid का derivative. ऐसे ही RCOOH में मैं अमोनिया डाल दूं. If I add ammonia, तो अमोनिया क्या करेगा? Again water will be coming. What you can take out is OH यहाँ से और H अमोनिया वाले में से. So in this case, what will you get is RCONH2. This is your amide. So all these are known as. This is known as acid anhydride. This is known as acid amide. तभी वो acid नाम क्यों लगा? Because all these are nothing but derivatives of acid only. अच्छा, और you can have, अगर मैं इसमें just see here, अगर इसमें मैं अगर add कर रही हूँ HCl, तो again take out water from here. So what this will form? RCOCl. This is acid chloride. ठीक है? So all these are formed from acids. So all these are acid derivative. Remember that alcohol acid या उसके किसी भी derivative के साथ react करेगा, तो it will always form an ester. And esters always have a fruity smell. It's a very pleasant odor. जैसे fruits की smell you find it nice, it is just a fruity smell. So what you can have is, say for example, I just put one or two more reactions for this. What you have is, you have ROH plus say RCO whole twice. So you can write your acidic anhydride also like R dash CO whole twice. So this again in the presence of an acid is a reversible reaction, and again you will get the same ester, R dash COO R dash. So you will have, और इस केस में क्या देखो, RCO CO, this was your anhydride, right? This was your anhydride. तो इसके अंदर जब ROH add होगा, तो you have your OR getting attached here, or say R getting attached here, and you have OH getting attached here. So what you get is R dash COOR, that's your ester, plus RCOOH. So acid is generated back again, and that will be the case with others also. You can check out the side product accordingly. Now you tell me what will be the side product when you add R dash COCl. It will again form R dash COOR plus HCl. Okay, so this is, all these are esterification reactions. Now next, a very, very, very important reaction is, you have this OH when it has a carboxylic acid at the ortho position, that's known as the salicylic acid. This salicylic acid reacts with acetic anhydride, that is CO. This reacts with acetic anhydride. Acetic anhydride is the anhydride of acetic acid. When it reacts with it in the presence of an acid, it forms, this is a very important reaction from entrance examination point of view. You get aspirin. Heard of aspirin? It is both an antipyretic as well as an analgesic. Antipyretic is the one which brings down the temperature to bring down the fever. That's antipyretic, and analgesic is pain reliever. Okay, so what you can form is, this is known as 2-acetoxybenzoic acid. 2-acetoxybenzoic acid plus acetic acid is formed. I repeat the reaction that remember that salicylic acid, when it reacts with acetic anhydride, it forms 2-acetoxybenzoic acid, which is nothing but commonly known as aspirin. Aspirin, and this is what it forms. Now, when we talk about other reaction, the reaction with this reaction, let me just put more reactions. There is one test for the distinguishing. There are in fact two tests that you can talk about for the distinguishing primary, secondary, and tertiary. Lucas and Victor Mayer test. Lucas test involves just the addition of HCl. अब आप खुद बताओ, जब हमारा अल्कोहल है, उसमें we add HCl, तो what is getting formed? When you add, what you have is, say you have RCH2OH. It's a simple question. And you're adding concentrated, say HCl, in the presence of anhydrous ZnCl2. So what will get formed? RCH2Cl. और हर केस में OH किससे रिप्लेस होगा? Cl से ही. तो ल्यूकास टेस्ट के रिएजेंट्स याद करो, कॉन्सेंट्रेटेड हाइड्रोक्लोरिक एसिड एंड एनहाइड्रस ZnCl2. ये तो पता होना चाहिए, टेस्ट बोलते ही रिएजेंट्स याद आ जाने चाहिए. तो ल्यूकास टेस्ट में यू आर एडिंग HCl एंड एनहाइड्रस ZnCl2. तो HCl जब हम ऐड करते हैं तो व्हाट इज गेटिंग एलिमिनेटेड? वाटर. और उस वाटर का क्या होगा? एनहाइड्रस. एनहाइड्रस मतलब ZnCl2 के पास कोई वाटर नहीं है, इट विल अब्सॉर्ब इट. सो वाटर को अब्सॉर्ब करेगा एंड यू विल गेट RCH2Cl. Now the test depends on how quickly you getting the turbidity or the cloudiness. So now you have to just talk about that only. So remember that when you are talking about this, for 1 degree there will be no reaction. For 2 degree there will be say cloudiness, white turbidity or cloudiness, which will disappear generally after 5 minutes. And for 3 degree there you have a cloudiness or turbidity which stays on. Okay, so this is like a very simple test. Now if all of you all correctly remember, as I rub the board, write down the reaction of alcohols to form alkyl halides. That is in the presence of PCl3, PCl5, SOCl2. Write it quickly, and HCl. These are nothing but the earlier preparation of alkyl halides are now the reactions of alcohols. So now next we can also talk, done. Alright, so remember now in this case when we are talking about dehydration, we'll be getting an alkene formed again. In this particular case of formation of alkene, the ease of dehydration for your alcohols, will be following the order 3 degree greater than 2 degree greater than 1 degree. It depends upon the reactivity order only. Because in this case OH can get cleaved easily, and because OH can get cleaved easily, you can actually have the ease with which your water can easily get moved off. Because OH has to get cleaved from one carbon, and from the next carbon you have to get the hydrogen getting removed. So in this case, this is an easy one, and you tell me what will be the product in this case. CH3, CH2, CHOH and CH3. You have to tell me the final dehydrated product obtained in case of 2-butanol after dehydration. So in this case, what will it be? 2-butene or butene. Alright, because, and this is from according to which rule? No. Markovnikov's rule is always addition of hydrogen halide. Markovnikov's rule always talks about the addition of some hydrogen compound to it. Now here we are talking about elimination or removal. So this is, yes, this is your Saitsev rule, which states that greater the symmetry, more symmetrical the alkene, better will be the stability and that will be formed. So in this case you will have Saitsev rule. Alright, another question that I have is, say this is your, yes, yeah, this is your primary alcohol. Let this be, say, T1. Then I have a 2-degree alcohol, say R, C, R dash, OH. Alright, that's undergoing this reaction H2SO4 to, of course, form another alkene at T2. And then you have R3COH. And this reaction undergoes dehydration at H2SO4 at T3. Now you have to tell me what will be the order of temperatures. You all understand that dehydration happens in the presence of a particular temperature. Now I have told you the ease of dehydration also. The ease is the maximum for tertiary, followed by secondary, followed by primary. So now I want you to tell me the order of T1, T2 and T3. T1, T2, T3. Why? Because 3 degree can actually undergo easy dehydration, so lesser temperature needs to be provided for that. So that is why it is around 358 Kelvin. Okay, next we can talk about in Victor-Weir test. Remember that you are adding phosphorus in the presence of iodine and then AgNO2. That's like a long test, but I'll quickly give you the test also. Here in this case what we have is, you have RCH2OH, you add P in the presence of I2 to form RCH2I. This will give, in the presence of AgNO2, will form RCH2NO2, which in the presence of HNO2 forms the nitrolic acid, which is RC double bond NOH NO2, which in the presence of an alkali gives a blood red color. Alright, for 2 degree again the same thing, but remember in case of 2 degree you will get at this step only, there is a difference that here you are getting a nitrolic acid. In case of 2 degrees, this is for primary, for 2 degree the steps are exactly the same. You have R2CHOH now, and your OH is getting replaced with iodide first and then it is getting replaced with NO2 first. यहाँ पे difference है that there it forms actually a pseudo nitrol. R2CHNO2 बनेगा, फिर उसके बाद 2 डिग्री के केस में R2CN double bond O, NO2 will be formed here, which is known as a pseudo nitrol, which on addition of alkene, also alkali, will then give a blue color. And for the final 3 degree, you will have of course now R3CI and AgNO2 will give you R3CNO2. Here after adding HNO2, this is all after adding HNO2, till HNO2 it's like more or less the same, there will be no reaction. So remember for the Victor-Meyer test, what you do is first you add iodine followed by NO2, I followed by NO2 is to be attached, followed by, and you had HNO2, HONO. So basically in case of 1 degree, what are you supposed to remember is what I am telling you. In case of 1 degree, you actually get the formation of a nitrolic acid. In case of 2 degree, you get the formation of pseudonitrol. But in case of 3 degree, what is the final thing that you are getting? R3CNO2. You get a tertiary nitro compound which doesn't undergo any further reaction because of steric hindrance. So your HONO has no actually space to basically attack and form any kind of a nitrile. And the colors are like elementary, so you can remember you have only you have a red color and you have a blue color. So Victor Mayer test is another important test then you can actually do. Done with it? What are the reagents? You just remember the reagents. You adding phosphorus and iodine in the presence of phosphorus rather, so that's forming your iodide. Then you add AgNO2 to form your nitro compound. Then you are adding HONO. In case of 1 degree you get a double bond NOH, which is a nitrolic acid, and in case of 2 degree you getting a nitrol, that is N double bond O. And then that with alkali undergoes further reaction, whereas in case of 3 degree there is no reaction. Now when we are talking about the reaction of phenols, see, you've understood one thing, that phenols are acidic in nature. So whenever we make phenols react with any of the metal ions, it will always form an ONA. ठीक है, लेकिन अब अगर मैं इसके अंदर, अच्छा, then if OH is showing plus R effect, मैंने लास्ट क्लास में बताया था जितने भी प्लस आर इफेक्ट शो करेंगे दे विल अंडरगो इलेक्ट्रोफिलिक सब्स्टिट्यूशन एट ऑर्थो एंड पैरा पोजीशन. क्यों? क्योंकि इलेक्ट्रोफाइल क्या होगा, मेरा कोई पॉजिटिव आयन जो आ रहा है वो इसीलिए आएगा इस पे क्योंकि जब मैं फिनॉल के रेजोनेंस स्टेबलाइज स्ट्रक्चर बनाते हैं तो नेगेटिव चार्ज सिर्फ ऑर्थो और पैरा पोजीशन पे ही बनता है. If you remember that. So if I'm adding now just Br2 in excess में मतलब वो सारी जगह पे फिर अटैक कर देगा. So in that case what will we get? 2, 4, 6. So that is at both the ortho and the para position you will get the attack of bromine. So it will form 2, 4, 6 tribromophenol. Okay, so that you can remember. Then similarly we can add other reagents also. If I add bromine excess में नहीं, in the presence of a organic solvent CS2, so then it will give you only ortho or para, either ortho or para. Now another reagent, remember this is like, sorry, that's an obvious factor. Now you answer this question. If I am talking about ortho and para, which is more symmetrical? Para. So naturally whichever is more stable will be existing in greater amounts. And again you know how to look into the stabilities. That depends upon whether you are talking about the liquid form, solid form or the vapor state. Now this is what? H2SO4 is a sulfonating agent. So you get what? You have to remember which reagent is getting which electrophile, SO3H. This electrophile will then form, so that means SO3H will come and attack at ortho position once and at para position the second time. Alright, another important reaction for phenol is when we are adding to phenol our concentrated HNO3 and concentrated H2SO4. So this will form what? NO2, that is 2,4,6 trinitrophenol, which is known as picric acid. Please remember the formation of picric acid is very important. You can get the formation of picric acid even from benzene. So benzene से either you make phenol, ठीक है, or from benzene you make aniline and then phenol, or from chlorobenzene you make phenol. क्लोरोबेंजीन से फिनॉल कैसे बनेगा? डाउस प्रोसेस. एनिलीन से फिनॉल कैसे बनेगा? डाइजोटाइजेशन प्रोसेस. बेंजीन से फिनॉल कैसे बनेगा? इट कैन बी अ स्टेप वाइज प्रोसेस और इट कैन बी अ डायरेक्ट आल्सो बाय एडिशन ऑफ सम aqueous reagent. Okay, so then this will give you picric acid. So I am not writing the formula now. And if you add a dilute HNO3 at room temperature, so then it will give you either a ortho or a para. Very good. All right. If I now add, if I now talk about another important reaction, because picric acid is an important formation. This is now like I can talk about the Riemann-Tiemann reaction. Riemann-Tiemann reaction is very important. Let me just write down the name itself. It is Riemann. I call it RT reaction. It is not the timer, it's the time up. So it is this. Now please remember the reagents right here, right now. Chloroform in the presence of aqueous NaOH at what, 300? Check out. So in this case, I am writing the final product now. What is the final product in this case? Salicylaldehyde. क्योंकि ये मैं जल्दी से समझा देती हूँ, हम अगर क्लोरोफॉर्म ऐड कर रहे हैं तो क्लोरोफॉर्म से जो भी हमारा जनरेट हो रहा है, व्हाट इज इट विल नेचुरली गो एट द ऑर्थो पोजीशन और पैरा पोजीशन. अब व्हाई इट प्रेफर्स ऑर्थो पोजीशन? बिकॉज इट इज फॉर्मिंग CH. देखो Cl निकल जाएगा एंड यू गेट ONA फर्स्ट. एक्वस NaOH ऐड करें तो एक्वस NaOH ऐड करने की वजह से हमारा सबसे पहले क्या बनेगा? ONA. ठीक है, अंदर का इसको ऐसे ही रहने देते हैं. ONA बनेगा तो यहाँ पे उसके बाद क्या होगा? CH-Cl2 will be the electrophile which will be generated. Why? Because H plus निकलेगा, it will abstract a Cl minus from here. Cl minus निकला, CH-Cl2 plus बना. और अगर प्लस इलेक्ट्रोफाइल बना है तो ऑर्थो या पैरा पोजीशन पे जाएगा. ऑर्थो प्रेफर इसलिए करेगा क्योंकि यहाँ से ये हाइड्रोजन इंट्रामोलिकुलर हाइड्रोजन बॉन्ड बना सकता है. तो ये क्या बनाएगा? CH-Cl2 यहाँ पे लगेगा. CH-Cl2 लगने के बाद हमारे पास एक्वस NaOH तो एक्सेस में है. तो NaOH जो एक्वस एक्सेस में है वो Cl को रिप्लेस करा देगा विद व्हाट? इट विल गेट द Cl रिप्लेस्ड विद OH and OH. रिमेंबर कभी भी हमारे दोनों OH सेम ग्रुप पे होते हैं तो दे आर नेवर स्टेबल. तो यहाँ से क्या निकल जाएगा? वाटर. एंड व्हेन वाटर गेट्स एलिमिनेटेड हियर सो इट विल फॉर्म CHO. So and when this forms CHO and you add acid again, it will form back your phenol on the top. So got it? In RT reaction, then what are you adding? What are the reagents? Chloroform and NaOH at whatever temperature. All right. So remember, in this case, you are getting salicylaldehyde, which is OH, followed by CHO. And whenever we bring about an oxidation of this, the oxidation of CHO will easily get it converted to COOH, and then in that case it will be called what? Salicylic acid. Okay. So these are some of the reactions that we've done for phenol. Otherwise, for the formation of, you now remember the Riemann-Tiemann reaction or timer time-up reaction. So in this case, you're adding chloroform to form salicylaldehyde. अगर हमारे पास phenol है और उसमें क्लोरोफॉर्म की जगह पे अब हम कार्बन टेट्राक्लोराइड ऐड कर दें तो विल गेट सैलिसिलिक एसिड. सो वी स्ट्रेट अवे गेट सैलिसिलिक एसिड. ओके. वन वेरी इंपॉर्टेंट रिएक्शन, फिनॉल से अगर बेंजीन बनाना है तो उसमें जिंक डस्ट डाल दो. ये रिएक्शन कुछ भी बनाने के काम आता है बिकॉज बेंजीन से सारी चीजें आप यू कैन गेट द डेरिवेटिव्स ऑफ बेंजीन इन ऑल द वे इन ऑल वेज. सो व्हेनेवर यू हैव अ फिनॉल you add zinc dust to it. What will it do? Zinc dust will just remove your OH and you will get benzene. All right. So there are other reactions as well, like just the last reaction for phenol. Phenol may you add say Fry's rearrangement is also one of the reaction. If you add AlCl3 to phenol, all right, what you can get first of all right, shall I put this reaction? No? Alright, we'll continue from here. But remember, when we've done alcohols and phenols today, in aromatic compounds, generally you just have to remember the reagent which is to be added and then you get the products accordingly. Ortho and meta will depend upon whether it is showing plus R effect. Once that is done, you are like through. The last reaction that we've done is phenol and we've added zinc dust to it. It just gives you benzene. The other reactions, I'm sure you will just revise them in about 10-15 minutes after the class. Alright, with this note, thank you. All the best.